So this is where I've decided to do my soil and landform survey in Cooper Park. It's about halfway down into the gully, so I'm hoping it's a good sample area of the transition between sandstone and shale, and kind of representative of the overall landform and soil in the park. That's the gully down there, and then you can see about halfway down the ridge here. It also extends up further that way. So you've got a mix of eucalyptus, some nice ground covers, and some ferns. I found an area here where I'm going to do the soil survey. Just an area that doesn't have too much ground cover or plants, so I won't be disturbing the vegetation here while I dig. So first of all, I'm going to give my tools a bit of a clean. I'm just going to use my wire brush to get off any dirt. And I'm going to use the disinfectant spray just to make sure they're sterilized. And I'm going to do the same to my boots. Okay, so I've dug my hole and exposed a profile of the soil. And first of all, we're going to look at the soil colours. So the topsoil is a kind of dark grey brown. Once you go a little bit lower, it becomes a little bit less grey, so it's just a brown colour. Beneath that is, get out of the light a bit, beneath that is a kind of light reddy brown, almost an orange colour, and then the bottom layer, once it gets to the rock, is a lot more orange. Okay, so the measurements for the different layers, we've got around 4 centimetres of organic matter. Beneath that we have the topsoil, and that's horizon A, and that's about 6 centimetres. Beneath that we've got horizon B, which is the subsoil, and that's about 12 centimetres. And beneath that we've got horizon C, or the parent rock, and that's about 10 centimetres, and I wasn't able to dig any further because I was hitting some very hard rock. Okay, so now we're going to do our pH reading of the soil. So I've pushed the pH meter into the ground. Try and get that a bit clean so we can see. Okay, so it looks as though the meter's sitting on about 7.5, which is fairly neutral, a very, very slight alkaline soil, which is good. Okay, now I'm going to do the break test. Okay. So it didn't break along a fault or anything. Okay, so I've got my hand lens here and I'm looking at where the rock has been broken open. As you can see, the grain shape is rounded and they're fairly large. I would say approximately 0.5 millimeter to 1 millimeter. They're visible to the eye. And as you can see, the break is uneven as it's broken along the grain boundaries, so it's a bit fragmented. And it does feel, it's not totally hard, it does feel like it has some porosity, which means that it may actually hold quite a bit of water, and it does feel quite damp. And I'm just going to do the acid test now. Got my lemon juice, which has a dropper top. Doesn't appear to be any fizzing, so that means there's no carbonate minerals in the rock. Okay, so next I'm going to do the hardness test. We're going to use the Mohs scale for this. So I've got a little kit here of different hardnesses of materials. I know that sandstone is generally harder than glass, so we'll start with the glass one, which has a hardness of 5.5. Just got a little perfume bottle here, and we'll see if the sandstone will mark the glass, and that will tell us whether the sandstone is harder or softer than the glass. So we'll just do this. Yeah, so I don't know if you can see there, that scratch just there. So that tells us that the sandstone rock is harder than glass. Next we have a little jug. The base here is ceramic, and that has a hardness of 6 on the Mohs scale. So we're just going to slightly scrape the rock onto the ceramic part of the jug, just to see whether or not it actually scratches the ceramic. Yeah, so you can see there it has actually made a mark. So the rock is harder than 6. Okay, so the next one I'm going to try some quartz. I've got some rose quartz here, and we'll just scratch the rock onto the quartz and see whether it makes a mark. Doesn't really make much of a mark, so let's try the opposite. Let's try scratching the quartz onto the the quartz actually makes a mark on the sandstone. So what that tells us is this rock is softer than quartz, so it has a Mohs level of less than 7, but it's harder than the ceramic. So we can kind of guess then that the sandstone hardness is about a 6.5. Okay, so now I'm going to go through the rock dichotomous key, which is to find out exactly what kind of rock this is. I have my suspicions that it is sandstone, but we will see once we go through it. So first of all, I'm going to look at the grains and just see. The first question is, are there any crystals? And there don't appear to be any crystals. Sorry, it's really unclear. No. So because there's no crystals, we move to the next question, which is, are there clasts, which are grains? And yeah, we can see that there are grains. Sorry, it's really hard to get a you have to just believe me that there are grains. So because the rock has clasts, we move to the next question, which is, are there large clasts? And no, we can see that they are quite small, smaller than a millimeter, but still visible to the eye. So no large clasts. So now we're at the last question, which looks at the size of the clasts, and it's asking whether they're medium-sized or less than medium-sized. Just by looking with my eye and just in the hand lens, I would say they range from about a quarter of a millimeter to around a millimeter, maybe a millimeter and a half. So that actually does classify them as medium-sized. Medium size is around 0.06 millimeters to 2 millimeters. So they are medium-sized. And so what that means is our rock is sandstone. So yeah, our rock is sandstone, and that means it is sedimentary, clastic, medium grained. Okay, so I've almost finished all my tests, and I've just put a sample of each layer of the profile into separate bags for testing. So I've got the topsoil here, I've got the subsoil, and I've got the parent rock. So I'll take those away. Okay, so now I'm going to do some ribbon tests on my 3 layers of soil. I've got my topsoil here first. I've rolled it into a small smooth bolus, and I'm going to try and get a ribbon out of it. I'll do a few and then just take an average. It's very crumbly. I don't think we're going to get any longer than that. Okay, so I've got a few ribbons here, and they're all around the same size, approximately 1.5 centimeters. So that equates to a sandy loam. The next ribbon test I'm doing is on the subsoil. I've got my bolus here. I'll do the same as the topsoil. do a couple more. Okay, so here are our ribbons for the subsoil. I've measured them and taken an average, and their average is about 2.7 centimeters, which puts it in the sandy clay loam category. Okay, so lastly we have our Horizon C soil, which is from the parent rock, and we'll do the ribbon test with this now. This one feels very sticky. Okay, so here's our ribbons for the Horizon C soil from Parent Rock. These are only a little bit longer than the subsoil. The average length is 2.8 centimeters, which also puts it in the sandy clay loam category, but I would say probably contains a little bit more clay due to the lighter yellower color.